The AES convention in Los Angeles in May 1972, I presented a paper on parametric EQ, first paper on parametric EQ. And at that session, I met David Blackmer. David Blackmer was the president and owner of DBX, but also had designed the VCA and some other key pieces of processing for API. The API VCA in its original form was a DBX 202X, I think, or some derivation of the original Blackmer gain cell, which is 2 NPN and 2 PNP transistors with op amps around them. And we know this because Dean Jensen and I pulled the potted module apart. Dean had a guy who could melt epoxy, and we took a look at his circuit, and it was clearly brilliant. But he didn't talk much about the circuit in public. We talked about it at the AES show before we both gave our papers, and I became deeply interested, enchanted with the idea of doing dynamics a different way, doing dynamics control, compression, limiting is dynamics control. Up until that point, I was running a recording studio. We had 1176s, Spectrasonics compressor, and I think we had an early RCA BA6. But I wasn't very impressed with these devices for wide range control. We of course, had to do a lot of hand mixing, and wouldn't it be great to come up with a better automatic gain controller, AGC? And I called the project the Dynamic Range Controller, and actually got early technology from David Blackmer, bought from DBX. RMS detection modules, VCAs, and started building what was to become the 8900 in 1973, late 1972, early 1973. Never had a product until I got together with Ron Pendragon at Nova Sound, our sound company for Earth, Wind, and Fire, and we had a project to build a better compressor, dynamic range controller, for vocals to take on the road with this group for this brilliant PA system, sound reinforcement system that we were building for Earth, Wind, and Fire for their tours in the late 70s. Big system, big bass reflex cabinets, lot of power, pretty inefficient, but very hi-fi. That eventually became the Series 1 Nova Research compressor, and there were a few of those around. It was fairly simple design with an RMS detector and a peak detector, period. And worked pretty well, but we took the idea on at GML that there had to be something better that could be more comprehensive and something that could really target recording vocals. So in the middle to late 1980s, I think it was maybe 85 or 86, we started work on what was to become the GML8900. Our chief engineer at that time was Michael Novich, who has gone on to greener pastures and is a great technology guy out of University of Miami, really good engineer. And we started designing what was to become a collection of modules that could be arrayed into into different forms of a dynamic range controller. But what it was a bunch of little analog computer modules, all surface mount, a log converter, wide range, wideband log converter, a RMS detector, a dual range RMS detector, a peak detector, gates, and a VCA. We listened and found that we were happiest with 2 RMS detectors. And what an RMS detector is, what RMS detection is, or RMS measurement is is when you take the root mean square of a signal. You square a signal, you take its average, and then you take its root. So we started there to try to build a detector that would do a better job at controlling voice, which is very complex. Average level detectors are okay. Peak level detectors are interesting. But nothing really gives you a magnitude quantity of the envelope of a voice quite like an RMS measurement. So we started there. An RMS module is a tricky piece of engineering where controlling the current density of the storage capacitor changes both the attack and release. And companies like DBX and us have ways of finessing that, giving you different attack and release controls. But the best way we felt was to have a dual range RMS, to have a fast RMS and a slow RMS. The slow RMS to give an idea of the envelope of the signal, and a fast RMS to pick up the peaks, so-called peaks. We also had a peak detector to pick up really fast peaks back when a lot of A to D converters would do nasty things if you went over range on their inputs. We don't use the peak detector that much anymore, but we use the two RMS detectors in a device that we call the 8900 dynamic range controller. The GML8900 dynamic range controller. Well, why is it called a dynamic range controller? Well, we think that there are key differences between the dynamic range controller concept and a compressor limiter, a compressor limiter. A compressor generally operates in the linear domain and acts on a signal to a greater and greater degree as you go deeper and deeper into compression. Distortion increases, the sound changes, the attack and release change. The release in the linear domain is exponential, not linear. So as you go more and more into compression, you get more and more distortion. The dynamic range controller is designed around a logarithmic context where all the signals inside are sensed logarithmically, handled logarithmically, scaled logarithmically. And it means that no matter how deep you go into compression on an 8900, it sounds the same. It's the same artifact out of the control chain at all levels. The degree to which you use the device is important to me because I wanted something wide range. Vocals are, especially with vocalists who are starting out as rock and rollers, are very wide dynamic range. I mean, back in the day, we used to compress on an LA2A 3, 4, 5 dB. Well, with modern rock and roll vocals, we're compressing to begin with 15 dB or 20 dB. I'm going to give us an example of a vocalist that took 25 dB or 30 dB of compression. We want that to sound the same we want to have the ability to let that sound the same for quiet parts and for loud parts. What this does is to give us an ability to control wider windows with a slow RMS detector and narrower windows with a fast RMS detector. Think longer windows being a vocal phrase, and shorter windows being one word. We have three detectors in the 8900. We have a peak detector, a fast RMS detector, and a slow RMS detector. The best way to show you how to use these is with music, so we'll play some things.